When we're going to then audit our information systems hardware, we have to look, do we have sufficient capacity to support business needs? Is there enough bandwidth? Is there enough memory? Is there enough processing power? So we want to ensure that there's a plan in place for forecasting and acquisition. If, say for example, we noticed doing an audit that there has not been correct attention placed to the fact that some of the equipment may really be reaching the maximum of its utilization, and yet there have been no plans in place to actually replace or upgrade that. That obviously is a weakness that should be brought to management's attention. We want to make sure that people are monitoring our systems. They're checking the logs and make sure that the systems are being operated in accordance then with the procedures of the organization. We want to make sure that old equipment is being replaced, that all of our equipment is being patched and of course properly configured. These are all parts of the important area then of hardware management. We want to make sure we have plans in place for the acquisition of new hardware or the replacement of existing hardware, so that we have the ability to ensure that the resources, especially the financial resources of the organization, are being directed towards acquiring what is the best hardware for our needs, which of course can be based on price, the ability to integrate, the skill level of our staff, and so on. Well, of course, there are many different types of computers. Over the years, we've seen everything from, of course, supercomputers right back to the old gray Cray machines, for example. But of course, some of the supercomputers in use today, and of course, this is where it's going to be very interesting to see the development of new quantum computing. But the idea of massive ability to do processing. And these supercomputers, of course, are used a lot, especially in types of government analysis and intelligence, for example. And then for many years, we've had the mainframe, the stalwart, hard-working big iron of computing services. And quite often these mainframes, which really are just a big computer, many of our server farms today have the same processing power as old mainframes. But mainframes have certainly been a valuable part of our computing infrastructure for many years, whether or not I own it myself, or whether or not I'm using it in a leased type of environment, similar to today what we call the cloud. And then we, of course, have many different types of servers: print servers, file servers, web servers, proxy servers. These are all the devices that provide support for different business operations. And the idea, of course, with these servers and with all of this equipment is, what do we have? Where is it? Is it being properly hardened and protected, for example? The idea of the cloud is really nothing new. It's just a really good marketing term. The idea of the cloud is to be able then to outsource, whether or not it's software through software as a service, whether or not it's infrastructure as a service, where the outsourced provider is managing our entire infrastructure for us, or of course the other option is then things like platform as a service, where a cloud service provider is providing the operating platform that maybe our applications or our databases then are running on. The idea of the cloud really is just the outsourcing then of that, should we say, technical function of the organization in one of those three ways. And of course, we have on nearly every desk today personal computers and laptops, which allow us then to interface with servers in the background and of course even things like mainframes as well. One of the options and architectures looked at for many years was the idea of thin client. Minimize the amount of processing power we put on a desk so that we're able to better manage, in many cases, the consistency of security. We're able to make sure that everybody's running from the same version and that machines are hardened and locked down to prevent many of the types of errors or even, we can say, attacks that could come through a PC. And of course, in today's world, we have a lot of bring your own device, the BYOD world, where we have then smartphones and tablets. We have all sorts of laptops that everybody's bringing into the office, wanting to connect it And of course, the risk, as we know with this, is what if that device is infected? Can that now spread onto the internal network? And this is where good architecture is important. What makes up a computer today? Well, the central brains, the CPU, obviously, central processing unit, our various input-output devices from keyboards and screens, and of course, other types of scanners and other types of input-output devices. Memory and drives, both the primary and secondary storage, as well as, of course, the various types of portable drives, USB drives, and so on that are used to connect. In order for us to connect our desktop to a network, we need a network interface card. And the network interface card, of course, whether or not it's wired using, say, a Cat5e cable connecting through an RJ45, or whether or not it's wireless connecting then through our network interface card off to a wireless access point, certainly that is a key component of allowing our system now to communicate with the rest of the world. And of course, USBs have been a tremendous benefit where we can connect everything from, well, today our monitors to, of course, USB thumb drives to keyboards. Almost anything can be connected using, of course, the standard format of a USB. So as an auditor, what's my job? My job is to make sure that we have inventory of all these devices. These devices are being properly configured and operated. We have policies in place about things like USB drives and so on. We know that there's a lot of risk associated with Universal Serial Bus. The idea being here of, well, if I've stored sensitive data onto that USB drive, and now, unfortunately, somebody steals that USB, hey, very easy to do, small, portable, easy enough to lose it. Do they now have access to my sensitive data? Well, this is where we should look at, are we using USBs that then have password protection and encryption on them as well? We know that USBs also can be a way to port malware or malicious code from one device to another. If that USB is infected, I'm now passing that infection around to anyone else who plugs in that USB. The idea that data can be stolen off of those little drives, in many cases, the problem with a lot of these solid-state type memory units is that it's impossible to truly delete the data that's on them. So a drive, even that's discarded years later, may still have the data recoverable on it.